Okay, in this first lesson, we are going to look at what a radian is. So we want you to be able to describe what a radian is, how to convert from radians to degrees, and also back from degrees to radians. All right, so what is a radian? 1 radian is the angle that intercepts an arc on the circle equal to the length of the radius of that circle. So here's a picture kind of describing that. If we were to take the radius, which remember is from the center to the outside, if I took that length and somehow curled it along the circle here, then the angle measured through here would be equal to 1 radian. Now, up until this point, you've probably only measured angles in degrees, and we're going to look at how you go back and forth between a radian and a degree later, but that would be what 1 radian would be. So if you wanted to do this, what you would do is on a sheet of paper, you could take like a compass, which we can use to make a circle, and you could draw a circle of any size, doesn't matter. Then if you took something flexible like a pipe cleaner and made it to the length of that radius, you could then curl that flexible piece of material around like we just talked about, and that would give you a way to draw out what 1 radian would look like. And it doesn't matter what size the circle, 1 radian is going to be the same angle amount. But what we're going to look at is what would 1 radian then be in degrees. So here I have one already done out. We're going to use a protractor then to approximate the number of degrees in 1 radian. So if I take this now and I set up the center on the center of our circle, you can see that it looks like 1 radian here is not quite to 60 degrees. It might be around, I don't know, like about 57 degrees or so here. So 1 radian looks like it's approximately equal to 1 radian is approximately equal to 57 degrees. Now, is that something you need to memorize? Not that specifically, but we're going to expand on that. So what would then, what are approximately how many number of radians does it take to make 1 full revolution of the circle? So if we wanted to take that and see how many fit around the circle, how many would there be? Well, we know in degrees that there's 360 degrees around the circle. So let's take and let's see what 360 degrees divided by our approximation of 57 degrees ends up getting us, and see about how many radians that would be here. So if we go to a calculator and we do 360 divided by our approximation that 1 radian is about 57 degrees, it looks like it's approximately 6.3 radians around a circle. Now that number, again, is an approximation, but it actually is very close to our exact amount of radians that it takes to go around the circle, which ends up being the number 2 pi here. So if you go on your calculator and enter 2 pi, you can see that that comes out to a number very, very, very similar to that 6.3 we came up to. In fact, if you round that to the tenths place, it is 6.3. And so what it ends up being is that there's exactly 2 pi radians around a circle. And so what a conclusion then that we can make is that 2 pi radians then is exactly equal to 360 degrees. So that is a known fact. 2 pi radians is equal to 360 degrees. That also tells us, doing a little math here, if we were to divide both sides of this equation by 2, that another equivalency is that pi radians is equal to 360 divided by 2 would be 180. So pi radians is equal to 180 degrees. And those are the most common ways of converting between radians and degrees, is either that pi radians equals 180 or that 2 pi radians equals 360. So those are two equivalencies that you should know. When converting, most of the time we do end up using the bottom one, but if you ever forget, that top one is a convenient one to use too. All right, so let's see if we can do a little angle math here and see if we can do some conversion. So example 1 here wants us to convert 25 degrees into exact radians. All right, so what we're going to do is start with our degrees here, 25 degrees. And we're going to use our conversion of 180 degrees equaling pi to do that. So we're going to multiply this by a conversion factor. And so a conversion factor is always going to be some kind of fraction here. Because we want our answer in radians, we want degrees to cancel out. So if I got 25 degrees here, kind of like in a numerator, I could make this into a fraction by putting it over 1. I want my degrees on bottom so that my degrees here are going to end up canceling out. And then 180 is equal to pi radians, and so that would be the conversion factor that we multiply by. So now multiplying these two fractions, if we multiply the numerators, we get 25 pi. If we multiply the denominators, we get 180. And so that's the answer, but let's simplify it here. We got some numbers that would go in there. So it looks like for sure 25 would go, or sorry, 5 would go into both of those numbers, and we could simplify that fraction out. Your calculator is also very good at simplifying these out. So let's put that in as a fraction, 25 over 180. I'm not going to include the pi there because then my calculator can't simplify the fraction down. So if I hit math, fraction, the simplified fraction of that would be 5 over 36 because 5 goes into both those two numbers. So then the simplified answer would be 5 pi over 36. And that's the exact amount of radians at 25 degrees is. Okay, typically you don't need to include the word radians. It's just kind of understood if you don't see the degree sign that your angle is in fact in radians then. All right, your turn. Why don't you pause the video, see if you can convert 122 into exact radians. All right, let's see what you got here. So you'd want to take 122 and multiply by our conversion here again of pi over 180, and what that's going to do is eliminate our degrees here. So now we're in radians. And the last thing would just be to simplify that. I think 2 is the only number that would go into both of those. So 2 goes into 180 90 times, goes into 122 61 times. 61's a prime number there, so that would be the exact amount of radians that this would convert to. All right, what if you want to go the other ways? What if you want to convert from degrees, or sorry, radians into degrees? Well, we're still going to use the same conversion. We're just going to do it the other way now. So we're going to start with our angle in radians. We're going to multiply by our conversion factor. This time, though, we want our answer to end up in degrees. So we want our degrees on top and our radians amount on bottom. These ones are actually fairly easy to simplify here because now when we simplify there, pi cancels out, and we just have to simplify out now this fraction. And so what does this fraction simplify to? You can do 16 times 180 and divide by 3 and see what that gives you. Also, if you could see some way to easily simplify, you can do that too. But let's just go hop on calculator here and we can do this. So if we do 16 times 180 and then divide it by our denominator number there of 3, looks like this is going to end up being the same as 960 degrees. All right, let's have you guys try one. So pause the video, see if you can convert 21 pi over 4 into degrees. All right, let's see how you did. Multiply by 180 over pi here. Our pi's cancel out. And then if you use a calculator and do 21 times 180 divided by 4, you should have gotten 945 degrees. So that many radians would be equivalent to that amount. All right, the next ones here, we're doing, again, some more conversions here. Let's see if we can do these ones without a calculator and see what we get. So first one, we want to convert this angle in radians to degrees. So our conversion here would be to multiply by 180 over pi. Our pi's should cancel out here. This one, we should be able to do without a calculator here. We just got 180 over 2 now. What's 180 divided by 2? Should be 90 degrees. Same with this next one. Looks like we'd want to do the same conversion factor here. 180 over pi. Our pi's cancel, so we'd end up with 180 divided by 6. That one, you could almost think of the 0 not being there. If you just had 18 divided by 6, that'd be 3. So if we put the 0 back on, this is going to be 30 degrees. Okay, so some of these are very easily done just in your head. Let's try some the other way and see if we can do those without a calculator. These are in degrees, and now we want to go to radians. So now we're doing the conversion factor the other way, pi over 180. So now we got 45 pi over 180. Is there a number that goes into both? Well, actually 45 does go into 180. If you think about 45 times 2, that'd be 90. And 90 definitely goes into 180 2 times. So it looks like 45 is going to go into 180 4 times. And so this would be the same as pi over 4. All right, let's try one last one. Again, same conversion factor here. So now we got 60 pi over 180. Well, 60 goes into 180 3 times, so this would be the same as pi over 3. So some of these are very quickly done, don't even need calculator to convert. So that's what a radian is and how you can go back and forth between radians and degrees.